Hi guys, so welcome back to another session of Sampai, and today we'll be doing a bit of simplifying algebraic expressions. I know some of the younger Form 1 to 3s have been looking forward to seeing this video for the longest while, and I'm finally giving you guys the attention you so rightfully deserve. So I'll begin with doing some very basics just to get you warmed up. By the way, algebra is my favorite topic in the whole wide world, and it will be reflected in this video, okay, guys? So some of the basics that we need to remember when we're simplifying algebraic expressions, like terms. So what if we have questions that look like, I don't know, say, 5y subtract x plus 3 minus 2y. How would we simplify an expression like this? First of all, I want to say that this contains 1, 2, 3, 4, 5 terms. Remember, terms are separated by that operation of addition and subtraction. Okay, so how would we begin simplifying? Well, first up, you need to group your like terms together. Some students cross them off, or some students underline them. Some students can see the answer right away. For the sake of today's video, we're going to take it just a tad bit slow. I'm going to choose to underline my like terms here. So like terms would be 4x and negative x. Now, please note that when you're simplifying algebraic expressions, guys, you must make sure that you take account of the sign that's in front of your term. A lot of students tend to add 4x with x and get 5x. They totally ignore that sign in front. The sign in front is extremely important. It tells you what operation you are actually performing between your like terms. So for example, in this question here, if I wanted to group together my like terms of 4x and x, I have to do subtraction. So I would actually be doing 4x subtract x. That gives us 3x. There we go. Now, we are going to move forward to grouping any further like terms. Let's see what we have. We have positive 5y and subtract 2y. So positive 5y subtract 2y will give us positive 3y. And then what's left? We have one constant that's standing alone. So we make sure we bring him down. Now, a lot of students tend to just write this. What's up with the sign? Where did it go? You must make sure you bring down the sign that was in front of your term. So we have simplified this question down to 3x plus 3y plus 3. Very frequently, you will have students doing this. 3xy, or some students may get 9xy because they multiply. They see that each of the terms has a common number in front, a common constant value of 3. So they assume that the constant makes the terms like. Therefore, you can group them through a process of multiplication, even though it's very clear that addition is taking place between these 3 terms. Like terms contain the same variable, not the same constant. Please remember that forever so that you never make mistakes like that. Okay, guys? So let's move forward to something a little more complicated. What about distributing brackets? Do you guys remember how to distribute brackets? What if we have 5x subtract 2y? How do we distribute brackets? Can you remember? Well, you have to multiply whatever is outside by each of the terms within brackets. Brackets means to multiply. So 5 times x gives us 5x, and 5 multiplied by negative 2y will give us negative 10y. And that's it. We have a subtraction sign between those two terms, and they do not contain they are not like terms, so we cannot do anything further. So that's our final answer. Let's look at a third example. What about if we have brackets raised to a certain power? For example, very common, x subtract 3 to the power of 2. There's two ways you can do this. One is a long way using the FOIL method, and the other is a shortcut. I'll show you both. So whenever you have a power, such as 2, and you have a chunk within brackets, usually it just means to multiply. If your power is 2, you're multiplying by itself to create a quadratic, and you use your regular FOIL method, which says to multiply x by x to give us x squared. Then you will multiply x by negative 3 to give you negative 3x. Similarly, negative 3 multiplied by x gives us negative 3x. And finally, negative 3 multiplied by negative 3 gives us positive 9. You can simplify those two terms in the middle, and you end up getting x squared subtract 6x plus 9. There's a shortcut way that does not include the FOIL method, and it goes like this. You simply, if your power is the power of 2, your brackets is being squared, and you have those two terms inside of your brackets, all you need to do is square the first term, so that gives us x squared. Then you square your second term inclusive of your sign, so that's negative 3 squared, that's positive 9. And then to get your missing middle term, you simply multiply both terms along with your power up top. So you would multiply x, multiply by negative 3, multiply by your power 2. That gives us negative 6x, and we'll write it in here. If you notice, obviously, it's the same answer. So this is a nice, neat little trick method that shortens the process of using the FOIL method. If you are willing to take a pic, memorize it, it's definitely worth your time. Okay, guys, so let's get into some real tutorial questions here, shall we? So one of the first questions on the tutorial sheet entails the FOIL method. And what I'll suggest you guys could do while I am doing tutorial questions, you can try your best to work along with me and see if you can perhaps get the answer out before I do. Okay, guys, so there we go. So our first question is, how do we calculate 3a subtract 1 all squared? Well, I'm going to use my shortcut here. I am going to square my first term, so that's 3a all squared. Then I'm going to square my second term, which gives us negative 1 all squared. And to get my middle term, I am simply going to multiply my first term by my last term by the power. Let's see what we get. So 3a all squared gives us 9a squared. Students frequently write this as 3a squared. If 3 is within brackets, you need to square your 3 as well. Moving forward, we have 3 multiplied by 2 multiplied by negative 1. That gives us negative 6a. So I'm multiplying my negative 1 by 2 to get negative 2. And then my negative 2 by 3 gives me negative 6. And I'll bring down my a. And finally, negative 1 squared gives us a nice neat value of positive 1. And there you have it. If you want to test this answer using the FOIL method, you can go ahead. Second example on our tutorial, we are going to look at a true question involving one where we have to use the FOIL method because both our brackets that we are multiplying here are definitely not the same. So using the FOIL method, we multiply our first terms. For those of you who don't know the FOIL method involves F. You multiply your first terms of each bracket, first by first. So 3 by 2 gives us 6x squared. Then we will multiply the outer. That means we have to multiply the two outer numbers. 2x multiplied by -4. That gives us -8x. Next up, we multiply the two inner numbers. That's 5 multiplied by 3. That gives us 15x. Finally, we multiply our two last terms. That's 5 multiplied by -4. That gives us -20. You can pause the video, you can press replay, and you can take your time, you can slow the pace, and you can get familiar with the FOIL method. I am going to move forward and simplify. So we can see that the only like terms we have present are the ones in the middle. And you'll notice that as you get more practice in, this tends to be the case every single time. Your middle terms are the only ones which can be safely simplified. So we have 15 subtract 8, that's positive 7x. And then we bring down our -20. Guys, the FOIL method always ends up producing 3 terms when you have questions like this. It's worth remembering that fact. So in the exam, if you end up getting something a little bit different, you can double check your answer. Of course, there are situations where you may get, say, one term because something eliminates, so you get a 0x in there or something like that. But generally, you'll get 3 terms for an answer, a question like this. Okay, so what about a question that looks like this? So we have a long one here. 3x minus y plus 4x plus 2y. How are we going to work this question? Well, very simple. We are going to distribute our brackets. 3 by x gives us 3x. We have 3 by -y gives us minus 3y. Then we have positive 4 by x is going to give us plus 4x. And then positive 4 by 2y gives us positive 8y. Now we are going to group our like terms. We have 3x plus 4x is going to give us 7x. And then finally we have -3y plus 8y gives us plus 5y. Please note that if you want a shortcut, you can use your calculators and you can simply plug in the numbers that are in front of your letters and you would get your actual numerical answer or your coefficients. Okay, so let's move on to a next question. This next question involves a bit of exponents, so it will do you well to review your rules of indices before attempting to understand this question if you have a lot of issues with your indices. So we have 4x squared multiplied by 3x to the power of 4 all over 6x cubed. How are we going to work this question? Well, we can cancel or we can multiply the entire numerator first and then we can cancel. I can do it both ways. Let's look on the left-hand side. And on the left-hand side, I am actually going to perform a cancellation. So writing out my question again, because we have a multiplication sign present between the terms on the numerator, we are actually allowed to cancel. you must cancel very carefully when you have fractions that involve algebra. So cancelling, I can see that I have x squared on top here, and I have x to the power of 3 on the bottom. So what I'm going to do is I'm going to cancel such that I cancel out 2 of my x's on top with 2 of my x's on the bottom, which will end up leaving me with 1x remaining on the denominator. Then I will go ahead to see if I have numbers that can cancel. Yes, I do. 2 goes into 4 2 times, and 2 goes into 6 3 times. What am I left with on the numerator? We have 2 multiplied by 3, that's 6x to the power of 4. All over, oh, we actually could have cancelled one more thing. We could have cancelled this x on the bottom, one of those x's with one of these x's, so that we have 3 x's left on the top. And also, we could have cancelled our 3's out. And that simplifies. We have 2 on our top, we have x to the power of 3, and on the denominator, we have absolutely nothing left. Now, it takes a lot of practice to be able to cancel carefully. It's easy to make mistakes, and that's okay. They usually show up after you perform multiplication. You'll notice that you forgot to cancel some stuff. The second way on the right-hand side, I'm going to show you how to do this question is by simply multiplying out everything. So what we're going to do is we're going to multiply everything on our numerator. So 4 by 3 gives us 12. And x to the power of 2 multiplied by x to the power of 4 gives us x to the power of 6. Remember, when you are multiplying the same base, you have to add your powers together. So 4 plus 2. Not 4 multiplied by 2. A lot of students tend to multiply powers, and this is definitely never the case. All right, guys. And finally, using our rules of exponents, well, first of all, let's simplify. 12 over 6 gives us 2. So we'll have 2 there. And using your rules of exponents, when you are dividing the same base and you have powers, you subtract your powers. So you end up with x to the power of 6 subtract 3, which gives us 3. So you can see that using either method, you are supposed to get the same answer. Algebra is such a unique collection of rules that a student can attempt a question in a variety of ways, and you can always end up getting the same correct answer at the end. The roots involved may be different. Everybody's answer may look different, but once you apply the correct mathematical procedures, you'll find that your answer is always on point. Okay, so let's move on to some more questions, shall we? So that's 4 examples here. Let me clear my screen and let's scroll up all the way top. This is my short break here. And we're going to try a next one that looks like that. So I think we're on number 5. So we're on number 5 here, and we're going to see one that has 4c to the power of 2 multiplied by 3c to the power of 4 all over c to the power of 3. And you can see that when we tried to cancel, it looked a little more bulky and difficult to see through. So for this question, I am going to use my rules of indices and exponents. So 4 3s are 12, multiplying my numerator together, noticing that I am multiplying 2 bases that are the same. I add my powers, 4 and 2 gives me 6. And I write back what I have on my denominator. And then finally, I simplify my same bases having powers of 6 and 3. I'll subtract 6 minus 3 gives us 3. Take note, if you can't remember, that the rule goes once you have the same base and you are dividing, whatever the powers be, m and n, your answer always works out to be x to the power of m minus n, which is the power of your numerator, subtract your power of your denominator. It's not necessarily the bigger number minus the smaller number. Okay, guys, just always remember that it's the power in the numerator, subtract the power in your denominator. Okay, so 6 subtract 3. gives me 3. All right, so let's move on to another example. We'll call this one 6 because it is question 6. La la la. Okay. So we have some nice ones here. I like these. So we have a nice horizontal question instead of such a fractionated one, eh? So this question is just going to be straightforward. We multiply the numbers. And if you're multiplying, you just simply add your powers. So we have p to the power of 5, p to the power of 2, that's 5 plus 2 gives us 7. And similarly for the q's, we'll add the powers 3 plus 1. So that's 4. Remember, 1 is understood to be present when a power is missing. And usually when you multiply terms together, you end up with one nice answer. That's what multiplication does. Addition, subtraction, they give you several terms. So it's worthwhile to remember that in the future. So moving on, we're going to look at a division. Okay, so what if we were given, let's just say something that looks like this, 5p divided by 3q. Okay, so we have another division sign, and we are having a division by a fraction, 4p squared divided by q. Looks cute, looks cute. All right, guys, so just like we would with regular fractions, we'll approach this question in this manner. You know, when you have a division sign between two fractions, what you usually do is replace it with a multiplication sign, and then you flip your second fraction. Well, you'll do the same thing. Just because it's algebra, that does not mean the rules of division of fractions has changed in any way. And I'm going to choose to, in this question, do cancelling a little bit, shall we? I'll cancel out my q here and here. And also notice that we have 2 p's on the denominator and 1 p on top. So I'll cancel that 1 p on top with one of the p's on the bottom. So we still have 1 p left on the denominator. Now on the numerator, we have left 5. And on a denominator, we have 3, 4 3s are 12, 3 times 4, and we have the letter P. That's your answer. Simple as that. If you wanted to, you could have multiplied the entire 5P by Q, and then you could have multiplied the denominator entirely and then canceled. You can choose whichever way you want, you'll still get the same answer. All right, so we're going to move on to, I think we're on question 8 now. And let's see. So far it's looking good. So we're going to be doing some fractions, subtraction of fractions here. This is a popular one that students tend to run away from. Whenever you have a subtraction or addition of algebraic fractions, guys, this is the one where you have to do LCM. Now, there's a very easy way to do the LCM. Usually, for algebraic fractions, all you have to do is simply multiply your denominators. So q multiplied by 3 gives us 3q. And you write whatever sign is present between, whatever operation, is present between your fractions. You bring it down. And what I like to do to help students understand what goes on top, because this is the tricky part for some, I tell them to just start from your leading diagonal, which is your first fraction there, and you want to try to cross multiply in a sense. So our first term that's going to belong here is going to be 5 multiplied by 3. And then on our right-hand side, we are also going to cross. You will get P multiplied by Q. Now, the order in which you cross multiply is very important. Your first cross multiplication must always be written first and start from your first fraction. You cannot write 5 by 3 second where you see P and Q. Once you have that in stock, you're good to go. We just need to go ahead and carry out our regular simplification. So 5 multiplied by 3 gives us 15 on top. Subtract PQ all over 3Q. And that's your final answer. Now you can choose to separate your fraction as it is into 2 separate fractions in the following way. So if you wanted to, whenever you have a numerator that has several parts, but your denominator is one term, only if you have one term on your denominator, you can separate your fraction in the following way. How many terms do you have on your numerator? 2. So when you're separating, you will end up with 2 terms. Your first term and your second term will all contain that same denominator. Your first term will contain the first value in your numerator, and the second will contain the second value in your numerator, And that's how easy it is. You can also see, you can simplify this further. We have 15 over 3Q, that can cancel. 3 into 15 gives us 5. So you have 5 over Q, subtract, and you can see the Q's are going to cancel here. So we get P over 3. Now, what do you guys notice happens here? When we split it up, you have gotten back your original question. So what I like to tell students is that when you are working out algebraic fraction questions, always try your best to leave your answer with one common denominator, no matter what topic you are doing. A lot of students tend to separate it out, and sometimes they make mistakes, sometimes they do not get back the original question, but a simplified format for an algebraic question that involves subtraction and addition is to get one common denominator. Right, guys? So this is what happens when you go ahead and you try to separate out your terms. You'll usually end up with your original question. Just wanted to point that out. Okay, so we are going to go ahead. We're on number 9 now. And I'm getting into my PK, but I'm sure some of you guys are getting tired, huh? Let's look at another simple example of subtraction, and then we move on to advanced one. So number 9, we're going to do, say we had 2 by a minus 3 plus 3 over a. How are we going to add these two algebraic fractions? Well, once it's a fraction and you're adding, you need to find the LCM, and the LCM is as easy as this. You simply multiply whatever you have as your denominators. Now, for the sake of simplicity, I am actually going to write my a in front, so it looks neat. And now we are going to perform the same cross. Starting with our leading, we are going to multiply in this way. So on the numerator, we will get 2 multiplied by a, and then we cross this way, you will get 3 multiplied by a minus 3. Another common mistake students make is they do not put that a minus 3 in brackets, because to begin with, there weren't any brackets. So why did I put brackets? Well, you see, if I did not write brackets, essentially, I would not really be multiplying everything across by 3. So the use of brackets makes sure that you are performing your multiplication correctly. So please take note that a lot of times in algebra, you have to introduce your own brackets in questions when you are doing them. And this is to ensure that your distribution is being done properly. Now, finally, in this question here, what we're going to do is clean up our numerator. We see we have brackets, so we need to distribute. So our numerator is going to look like this. We are going to leave that 2a there. Then distributing our brackets, we get 3 multiplied by a gives us 3a. And then finally, 3 multiplied by negative 3 will give us negative 9. On the denominator, you can choose to expand brackets or you can choose to leave your brackets alone. It depends on if a simplification can happen. And one last step, on your numerator, we can simplify 2a plus 3a to give us 5a, subtract 9. And on your denominator, if you want, you can expand brackets so that you get a by a gives us a squared, and a by negative 3 gives us minus 3a. You could have left your denominator as a over a minus 3, such that you had 5a minus 9 all over a by a minus 3. Either of these answers are correct. Usually, I would have written my answer like this. Generally, a point to note is that simplify your numerator as much as possible by expanding brackets and leave your denominator alone by not expanding brackets. Hint, hint. Okay, guys, so that's how to do question 9, a nice, simple fractionated question. Let's look at another example with these fractions. And there was a request for these fractions, which is the reason why I'm doing so many of them. A lot of my students wanted to see tons of examples on how to add and subtract algebraic fractions. So I'm just trying to do as many different variations of them as I possibly can here. What about this one? What do we do? I mean, the denominators have no letters. Does that mean they are not algebraic fractions? Well, they are fractions and they have letters, so they must be algebraic fractions. Therefore, we have to find the LCM still, guys. To find the LCM, we multiply our denominators. 3 by 5 gives us a nice clean number of 15 this time. And once again, we are going to perform that cross starting from here. So we are going to multiply our 5 by our x minus 3. We're going to bring down our subtraction sign in the center. And then we are going to cross this way as well. Notice that when I'm crossing, I'm trying to place my single digits in front and then my brackets after. It looks neater, and essentially you want to develop the skill and the habit of writing your coefficients in front of those large chunks. Now on my numerator, I can see I have brackets. So remember I said from the question before, you want to try to simplify your numerator by expanding brackets and leave your denominator alone. So expanding that numerator, we will get 5 by 3 gives us, 5 by x gives us 5x. And 5 by negative 3 gives us minus 15. Then we have minus 3 by x gives us minus 3x. And then minus 3 and minus 2 gives us positive 6. We can simplify this to get 5x subtract 3x gives us 2x. And negative 15 plus 6. Notice I'm using these signs in front. Negative 15 plus 6 gives us negative 9. And we simply write back our denominator. And that's the answer for a question like this. I'm going to do probably just one or two more, and then we'll call that a session. I don't want it to be too long. Okay, guys. What if we had an interesting one, say, for example, like this. 2 divided by x minus 1. Subtract 3 divided by x plus 1. What happens here? Well, we'll just go ahead and multiply our denominators and leave them as they are. And we perform our cross starting from that first one. So we'll get 2 by x plus 1 subtract 3 by x minus 1. Now on the numerator, we need to expand those brackets. So expanding, we will get 2 by 3 is going to give us 2 by x. I keep saying by 3. 2x, 2 by 1 gives us plus 2. Then negative 3 by x gives us minus 3x. And negative 3 by negative 1 gives us plus 3. On my denominator, I'm going to leave it as it is. X minus 1 by x plus 1. You can use the FOIL method, but it looks very nice and clean as it is. So I'd rather you leave it as is. I'm going to write back my denominator here. And one step further, I'm going to simplify my numerator. I can see I have common terms. 2x subtract 3x gives me negative x on top. And I have positive 2 plus 3. That gives me plus 5. If you wanted, you could have rewritten your numerator as 5 subtract x. But this answer is perfectly fine. Okay, guys, so I'm going to do one more question on screen. You can choose to play over the video. If you didn't understand an example, you can play it. And, if you have questions that you still haven't seen in the tutorial that you really want to see, you can always message me. Are we on question 11, I think, or 10? I'm just going to write a question because I can't remember. Okay, so what if we have a question like this? And it looks like there's nothing we can do to simplify. What can we do? Well, for those of you who have done factorization already, you should, and I'm saying should, you should be able to recognize this as the difference of two squares. All right, this is the difference of two squares where we have two square numbers being subtracted. This is really x squared subtract 1 squared. And that breaks up into x plus 1 by x minus 1. And your denominator, if we were to write it back here, you'd notice that we can cancel. And canceling just gives us a nice clean answer of x plus 1. Now, a question like this is very straightforward to do if you are able to recognize that it was the difference of two squares. So quite interesting that it was a simplification of an expression, yet you had to have that knowledge of factorization. And I think essentially this is where students tend to get fearful. Sometimes they want questions to be straightforward, using the basic rules of indices and distributive rules. But, when a question like this comes, and then you have to think of factorization, difference of two squares, it starts to get challenging. But the more you practice, the easier these concepts are to see within questions. So that's the key, kids. What you need to do is expose yourself to a variety of questions. Keep practicing, keep trying. You don't have to essentially do maths like every single day of your life for hours on end. You can do, you can allocate perhaps a half an hour. I'd say if you're in a lower school, you can allocate an hour 3 times a week where you practice a series of questions, and you would be surprised how good you are going to get. But you must include that practice. Mathematics is a subject that requires a lot of practice to get the hang of it. Teachers, if they stop teaching, I'm sure we would forget a lot of stuff in a very short space of even 2 to 3 years. Trust me, it happens. So everybody needs practice, okay, guys? So I was so happy to do this tutorial. I am hoping someone asks me for another one on algebra, but as you guys know, I'm still working, trying to finish out the vectors tutorial for the Form 5s. So if I have any viewers from different countries, yay. If I have viewers who are writing SATs, perhaps, I am sure these tutorials would be beneficial to you as well. And I hope it helps. If it does, give me a thumbs up, leave comments down below, and be sure to like my video and share. Okay, so thanks, guys. Hoping to see you guys next time. Bye.